So today we'll be doing a demo on how to create an operator using Go programming language and operator SDK. We'll set up an environment and implement a basic operator using Memcached as an application and deploy it to OpenShift cluster. All of the codes and files that I will be using part of the demo is available at the GitHub link in the screen. Operators can be built using Go, Ansible, or Helm. In this demo, we'll be using Go to implement our operator and Go programming language. So what does Operator SDK provides? Operator SDK is a framework that uses controller runtime library to make writing operators easier, and it provides quick tools for scaffolding and code generation to bootstrap a new project. It also provides high-level APIs and abstraction to communicate with your Kubernetes or OpenShift cluster. It also has extensions to cover common operator use cases. And it also has quick tools to build your image, push your image, and deploy it build your operator to OpenShift cluster. Before writing an operator, we need to have our environment set up. The following prerequisites that you see in the screen has to be installed before you start writing an operator. You need Golang because we'll be using the Operator SDK and Go programming language to create the operator. We need Kustomize to manipulate and modify YAML files on the fly. We need kubectl CLI or OpenShift CLI. And in this case, since we will be deploying to OpenShift cluster, we'll be using the OpenShift CLI, OC as a short name. We need Docker to build the image. We'll be using OpenShift cluster. I already have OpenShift cluster ready. And you need a proper and adequate permissions in the cluster so that you can run commands in your cluster. And you also need to install Operator SDK so that you can initialize your project and then create APIs and spec and then implement your operator. So let's create a directory called Memcached operator and let's initialize our project there. So in order to initialize our project, we need to run the Operator SDK init command, and we'll provide our domain and repo as a parameter. The domain flag is basically the unique identifier for the operator. We also need to properly set our Go modules in one of the files, go.mod, and also activate the Go module support by running the export command for Go module. It will take a couple of minutes to finish running this. So once the init command is run, we need to create an API and spec. So from the command line, we'll run this create API command and provide a group, version, and kind as a parameter. Along with that, we'll also have a controller and resource parameter. The group flag basically defines an API group in Kubernetes. It is a collection of related functionality. Each group has one or more versions, so we'll also supply a version as a part of the parameter. Each API group version contains one or more API types called kinds. In our case, we're going to name it Memcached. The controller flag signifies that the SDK should scaffold a controller file where our main logic resides. And the resource flag signifies that the SDK should also scaffold the schema and other resources and configuration files. So let's run that command as well. So we're going to say a yes here. So once it's completed, we'll update the API. So before updating the API, let's look at the files and folders that it has generated. So let's look at the project it created after running the initialize command and the create API command. It has default files with default configuration. You can see that the API has been created in file called memcached_types.go. It also has other configuration files, the default configuration files. It also has created the controller file where our main logic resides. And the main.go file is initialized the main controller file. And you'll see that there's a make file where it provides different commands to build, push, and deploy your operator. So now let's create an API and custom controller for Memcached operator. Oh, sorry. I think we should cut this down. This different one. Starting again. Let's update the API as per our need. The API is defined as a Go struct in Memcached spec and Memcached status. So modify the spec and status to include the size, which is the integer, and it resembles the number of replicas that you'll be deploying in your OpenShift cluster. And in your Memcached status struct, we'll be adding node. It's an array of string, and it defines each node with their state. So we need to modify the existing default parameters according to our needs, which will be the size. And in the status, we'll be adding the nodes as a string. So now the next step is to implement the controller. The file that the operator SDK generated, which is inside the controllers folder, memcached_controller.go, it has a reconcile method. So the reconcile method gets called every time the desired state doesn't match the actual state. So to implement the reconcile logic, we need to implement the following. We need to first make sure we get the Memcached instance, and we will create the deployment if it doesn't exist. The deployment will basically deploy the Memcached image into the cluster. We need to make sure the actual and desired state match. And at the end, we'll update the Memcached pod names with their status. So let's go into the code and change that. So this is the Memcached_controller file, and it has reconcile method. And this is where all the logic resides. So here we'll be implementing all those 5 steps that I had mentioned earlier. I'm going to copy already written code into the reconcile method, which does those 5 steps. Sorry, I'm jumping here and there to find the problem. Okay. So now in the reconcile method, you can see that all the code has been pasted here. The first step is to get the Memcached instance. The second step actually creates the deployment if it is already not created. The function deployment for Memcached actually creates the deployment for Memcached, and we are using the Memcached image with version 1.4.36-Alpine as a version. Next step is to make sure in the actual state and desired state are the same, and the other steps includes updating the status with pod names and their state. So once this is done, you have written your basic Memcached operator to deploy the Memcached operator into the cluster. Now, once you're ready, the next step is to compile, build, and deploy your cluster. You need to run a set of commands that the operator SDK provides to basically generate the code, make sure it compiles, and then you also need to make sure that you have a proper namespace and image set into your configuration files, and build, push, and deploy your operator. So we need to run make generate and make manifest and make install command to basically generate the CRDs based on the API changes that you made earlier. We added like size in the spec, and all the nodes with the names and state into the status. So we need to generate the CRD for that one. So we need to run make generate and make manifest command, and make install basically compiles the code and make sure it's running. And the customize command basically customizes the YAML file, the configuration files on the fly. So we will be editing the namespace and putting our proper namespace in there, and also setting the proper image name inside the configuration files. So all of these commands, we can put it into a script and then run it all together. So let me show you the script as a whole. Pausing for a while. Starting again. Okay, the script as a whole looks like this on the screen. You need to set your proper image here. That's my image where the operator will be hosted. And this is the namespace. The namespace comes from OpenShift cluster. It's the name of the project that you'll be using to deploy your operator. And all the rest of the commands are here. Once this is done, the operator will be deployed. And next step is to basically change your custom resource instance, provide the values, and deploy your operand. So let's run this script. So while this is running, before you run this command, you also need to log into your cluster. So if you go to your cluster, and open OpenShift Web Console, there's a copy command. Once you click that command, you'll get a token, and you can copy and log in into your cluster using this OC login command, and you'll be logged into your cluster. So before running the build script, you need to log into your cluster. So as you can see here, all the commands and all the statements in the scripts are running fine. Looks like the script did finish. At this point, the operator controller has been deployed. So manager controller has been deployed. So let's look at that by running command get paths. So you can see that the Memcached operator controller manager is running fine. So next step is to deploy your operands. To do that, you need to change your custom resource instance, and based on our API, provide the spec, and the integer value depends on what you want, not the number of instances that you want to deploy into your cluster. So let's make a change to our CR instance. So the CR instance lives in samples cast view and alpha1 memcast.yaml. So since this is the default value, we need to remove that, provide the size. Let's make it 3 for now. And in order to deploy the operands, we can apply this file into our cluster by running command. So now let's make sure that our operand has been deployed. So since we have provided three as a parameter in our API, there are 3 replicas running here. We also can check this and verify this from our OpenShift cluster as well. So let's go to our project. The project name that I have used is Sanjeev-demo. And you can see there are 2 deployments running. Let's see the memcast sample. And you can see that there are 3 pods running. The other things to test here is how to scale or descale your instances. There are 2 ways, and there's only one way to do properly. You can increase or decrease from here. It will scale to 3, it's scale to 4, but this is not the right way, right? Because the desired state is defined in the custom resource instance, which is 3 in our case, right? So since even though we increase this from here, from the OpenShift console to 4, and it realizes that the actual and desired state is not matching. So the number of instances will go back to 3 at some point. It will take some time to decrease the number of pods back to 3. So this is going to take some time, so I'm going to pause for a while. So as you can see that the number of pods has been back to decrease to 3 because the cluster realizes that the actual state is the desired state is basically 3, which is defined in the custom resource, right? So if you really want to scale or descale the number of instances, what you can do is you can modify your custom resources. Let's put it back to 4. And then we can apply this to our command line. And now the desired state is 4, right? The size is 4. So that means your operator looks at your CR instance, and then it runs the reconcile method to redeploy the remaining instances, which is 4. So pausing for now. This is also going to take some time to bring that fourth pod one. Okay, the fourth pod has already been deployed. Let's also make sure the cluster is showing the 4th pod as well. So as you can see that the 4th pod or 4 instance has been deployed.